Thank you everybody for joining us today. So my name is Felipe Costa, I'm a solutions architect here in the United States, based in Dallas. My main role here is to help customers to move security to the cloud, move their security controls to the cloud, and in general to secure their application lifecycle. And we're going to discuss a lot of these different components here in this webinar today. So I have a couple of slides that are going to just contextualize a little bit what I'm going to talk about and how the cloud native applications has been used these days. And that's it. So let's talk about a little bit about cloud native applications. So cloud native applications are not a single component that you can just deploy to the infrastructure. So cloud native applications is a concept that you can put on different many services. So compared to the most traditional way to build, create, build, and deploy applications,
I don't know how to respond to that.
Cloud native applications are actually different components that you can decentralize your own application on multiple different components. So in a more traditional way, what we can do is we can build some code and we can manually build this code using packages for different programming languages like Python, Java, Node.js, and many others. And then at some point, you want to deploy this to a server, like you can say a Linux server and host a web app inside of this Linux server. So this is the most in the traditional way. Now with cloud and specifically cloud providers like AWS, Microsoft Azure, Google Cloud, you have many other different ways to decentralize your application into a single component to a microservices application or a multi-component application. So instead of having your application just installed on a single server, you can have different other piece of technologies like containers. So you can have a Kubernetes managing all your containers and you can deploy multiple containers for different functions. You can have serverless functions like Lambda functions or Azure functions to processing some different information across your the flow of your application. So as you can see in this screen, you have many different other ways to actually build your own applications instead of just building some code and deploy to a single server. But with all of these components, we can ask ourselves how security practitioners, they're going to understand how to secure this new set of services for their developers' applications, how they're going to secure that if they don't actually understand how they work. So the main idea here is to actually be able to understand at least the architecture of the application and the flow that developers use on a daily basis to be able to go to these different components and apply the right security controls to these components. Because with this new set of technologies, a lot of different other vulnerabilities come across this new architecture. So you can mention it, for example, vulnerable container images, you can see misconfigurations being introduced to your cloud environment. You have SQL injections inside of your web applications. I have malicious file being uploaded to cloud services like Amazon S3, for example. So there's many challenges that customers are facing with this new set of technologies that applications are using these days. And this is the actual paradigm of the cloud native applications and how to secure them. So let's jump a little bit inside of Train Micro Cloud One platform. So the Train Micro Cloud One platform is a platform that we created to actually help customers to actually secure all of these different components inside of a cloud native applications and help also customers to have a holistic view across the whole cloud environment and also migrate from the on-premise security controls to cloud native security controls as well. As you can see, it's a SaaS platform. We are cloud provider agnostic, which means you can deploy the security controls to AWS, you can deploy to VMware on on-premise environment, you can deploy to Google Cloud, you can deploy to Microsoft Azure as well, and many other cloud providers as well. And inside of the platform, you'll be able to choose what kind of service you want to use. You need to secure your cloud storage or Amazon S3 or Azure Blob Storage. You can use Firestore Security for that. So you have many different services, each service designed for specific needs in the cloud security that you have on these days. So the today focus is actually to talk about application security. So application security was created to help customers to deploy security controls directly to their APIs, web APIs, to their web applications, and to their serverless functions and serverless containers as well. So let's talk about the challenges to secure web applications in the cloud. So the main challenge that every security professional has these days is the ability to keep at the same speed as developers pushing code to production in these fast releasing cycles. So many companies are using DevOps concepts, maybe not in 100%, using all the DevOps tools and concepts these days, but at least using some of them. And traditional security is very difficult to change as much as we can to actually fit on all of these different needs. So we need something that actually security teams can keep at the same speed as developers. They move to different platforms, they move to different cloud providers as well. And another thing that became a focus for security practitioners to be able to secure is APIs, because at some point in the past, we use databases and have different type of communications that we can use to share data across the company. So now developers, they're actually using more and more APIs to actually do that, to share data across the whole organization. So instead of creating integrations for each one of the departments that need to access your data, they can just build an API and all the departments will be able to query this API to get the information that they need. So it's very comfortable and very productive for developers to build these APIs to actually be able to share all of this information across the company. But at the same time, this is a totally different technology that you're not used to. So we need some kind of different security controls and different security even platform to be able to secure these APIs to make sure that when you're sharing data across your company, this data will be shared securely and have the proper access control to all of this data being shared in the company. So talking a little bit more about Cloud One application security and how it works. So Cloud One application security, as we call it, a RASP technology. So runtime application self-protection, which means we are focused to protect customers at the runtime. So we're going to give visibility and also give protection for the applications running at the runtime. And application security, as I mentioned, is more focused on the serverless part of the deployments that customers may need. So in the Cloud One platform, you have many modules, as I mentioned, so you have container security and you have workload security. So if you're using serverless functions and you're using serverless containers, application security is the technology that we design to actually fit on that need. So the idea here is to be totally cloud agnostic, which means give the flexibility to developers to move to any platform they want. And the runtime, we're going to keep this runtime attached not to the operational system, not to the cloud platform, but directly to the code. So in the more traditional technology for securing web applications, you used to go to the server and install an agent, and then this agent is attached to the operational system to help protect the application that is there. Now, in serverless function, we don't have a host OS to actually install this agent. So how are we going to provide runtime security for it? So Cloud One application security attached directly to the code that you have inside of your application, your Python code, your Java code, your Node.js code, directly built inside of the code. So instead of changing your code to fit inside of the security needs, we can just add 2 lines of code to make sure that this micro agents that we have is going to go up and running together with your application. And then you'll be able to provide different security controls. We'll be able to provide our anti-malware analysis or anti-malware engine. You'll be able to provide IPS for applications. We're going to provide also web application security focus, like protect against remote code execution, SQL injection, and many other features as well. So this is the main idea, and this is how the architecture actually works. So have our platform where you can have the console and you'll be able to see you can able to change the security controls that you want to apply to that serverless function or to that container specifically. You'll be able to see whatever blocking capability you have in place or detection or visibility that you have. So we'll be able to see this on a single platform. And then at the same time, in the application stack, you'll be able to make sure that these policies are in place. So instead of going to the host OS and install the agent and everything, we add this to the line of code for your Lambda functions, for your Azure functions, for your Docker files, for your containers. And then as soon as these containers or Lambda functions are working at the runtime, we'll be able to provide the protection and monitor 24/7 these different components that you have. And at the same time, the end users in the other side of your application will interact with your application by uploading files, by interacting in the network way with your applications, and then application security will actually be protecting your applications for being exploited as well. Okay. So the main idea, what kind of problems we're trying to solve with application security, we'll try to provide a very flexible way for detection and protection to this new set of technologies that cloud native applications are actually using it. And at the same time, all of this is built for a restricted environment where you don't have a lot of access to the host OS and to many other different components. Just have access to the code, and then we build that directly to the code, and you can run it, and it's good to go. You'll be able to control, the security teams will be able to control, even if the developers, they change platform, they change cloud providers, they change from containers to serverless, they can change, they have the flexibility to change a lot of different upper platforms, but for the security teams, doesn't actually matter as long as they are building that inside of the same Python code. For us, it's good to go. We'll be able to protect all of these different applications. Doesn't matter how many changes the developers, they push for different other platforms as well. So as I mentioned, it's built for cloud native applications and it's platform agnostic. So it doesn't matter what kind of platforms you are using these days. And the ability to make a lot easier to actually deploy that instead of installing agents, stopping OS systems like Windows and Linux. So you can just be able to attach this to the code, and developers, they can run, they can build their own automation across their pipelines, and security teams will still have visibility and ability to deploy the protection, to make the protection in place. Okay. So just a glance about the features that we have for application security. So we have detecting and blocking capabilities for network attacks. So we're talking about SQL injection, remote code execution, and even vulnerabilities like Log4j, for example, or shell shock, or many other common vulnerabilities that will target your APIs and your web applications. You'll be able to make sure that all of this protection will be in place for your applications. We can also identify some kind of code level of vulnerabilities, like I mentioned at remote code execution. So if there's any vulnerable packages in your code, you'll be able to actually apply some security controls to it. And even if your application has some kind of upload capability, so your end users are uploading files, you'll be able to enable the malware scan directly to the serverless application. So before that file even touches your databases and touches your Lambda functions, for example, we have a hook to be able to scan this file before it actually goes through your application. So you'll be able to block this file or allow the file to go. So have some kind of anti-malware scanning capability over there as well. Okay. So let me actually jump to a very simple demo here. So I don't want to focus on the topology of the application because many security practitioners, they don't have access to how the application actually works from inside. So I'm taking a cloud native application on a very simple way. So this is, we can say, like a cloud native application starter pack. So this is the most common kind of use case that developers use today. So they need some kind of front end, and then they have some kind of serverless function to actually processing wherever the users are interacting with the front end with their application. So here I'm showing an example for AWS, but actually going to work at the same way for Google, for Azure, for any other cloud providers, because all of these services that you're seeing here, they're common across all of them. So we have serverless function to process the back end of the platform. So I have some kind of front end here. So in this case, I'm using S3 static website to post HTML page or my static web page. And then I'm interacting with the API gateway, where I can have a URL to send data across my cloud account. And then this, as soon as I access this API gateway, this will trigger a backend function, in this case, a Lambda function for AWS, to actually processing some information. A use case for that might be insurance company that will receive files from customer and it'll process that and I put that on a database or even on an S3 bucket in that case. It's just a very simple example. So I have this backend portion, as I mentioned it, and I have a way to record this to a S3 bucket or to my database, and I have the front end piece of my software here. So let's go real quick here. I have my application. So this is the front end of the application that I mentioned, stored on an S3 bucket. And then let's go to the Cloud One platform. So let me log in to my platform. As I mentioned, it's a SaaS platform. So you can go inside, and then I have multiple services that I can use. So I have containers, and I can have workloads, and I can have network. So today's focus is to application security. Inside of the platform, we actually also have common services. So it's a single documentation, single API. So if you want to query information across different services here in the Cloud One, you have a single API to actually be query all of this information, and have single user management as well. So you can invite many other security engineers from your team as well. So let's go to the application security part. So here I have many different components. I can see all the events for my Lambda functions and for my serverless containers as well. And if I go to the groups policy, I can change the policies. So for example, here I have my Lambda app, and I have many different security controls. So I have malicious upload, that is essentially my IPS. So in my IPS, I can enable or disable different vulnerabilities. I have old vulnerabilities and I also have new vulnerabilities. Log4j, for example, is the most recent outbreak that we have. And this is enabled by default as well. And I have many other different security controls like malicious file uploads, that is Train Micro anti-malware engine applied to the application security. So I can enable, disable, I can put buffer size, I can select the maximum file size that I want to scan, and I can have a flexibility to choose many other different parameters. As long as I have this enabled, that should be able to protect your Lambda functions. The only thing that you need to run inside of your Lambda functions, there is a layer that you can run on your Lambda functions, so we'll be able to actually deploy the protection in place for your serverless function. For Lambda and for AWS more specifically, we also have assessment service where you can connect your AWS accounts, and your AWS accounts will give us access to the Lambda functions, and you can see how many Lambda functions you have without the protection in place. So since I already deployed this just to save some time, for our Lambda functions, I will have two protected functions, but in the same account, I have two accounts added here. I have 93 different Lambda functions that I did not add the layer and I did not configure the policies to it. So this gives me visibility on how many functions the developers they are deploying and how many functions are not actually using the protection for Cloud One application security as well. Another cool feature here is that I can see in the code what kind of packages by Train Micro open source security provided by Snyk. So we'll be able to also see what kind of packages were actually vulnerable inside of the Python or in the Java or in the Node.js code. So here in this case, for the two Lambda functions that deploy the protection, I have vulnerable packages using inside of my code. So if I click on the packages, I will have the ability to see more information about how vulnerable is this packages and how I can fix these problems, help developers to actually fix this problem as well. Okay, so let's go straight to the group policy here. So let's go to my Lambda functions. So in that case, I will make sure that we can have a malicious file upload in report mode. So I'm going to upload a file, and this will log directly to my Lambda function. So the Lambda function should not block the file right away. And then as soon as I change that to mitigate, it will be able to block this file before it actually reads any part of the back end of my application. So let me go here to my Lambda code. Let's select malicious file upload, and let me actually upload a file. So, oops, choose a file, and then we can actually upload many different files here. So in that case, to simulate the actually user uploading a file, let's upload a confidential PDF. That could be actually anything. So if I don't check the extension, if I don't check different parameters inside of the actual file that the user is uploading, I won't be able to check anything. But with Cloud Run Application Security, as soon as I deploy this to my Lambda function and activate the protection for my Lambda function, I will be able to actually monitor if the file that is being uploaded to my system are actually malicious. So let me go here, and the file has been attached because I didn't put any protection in place. So if I go to my events, I'll probably be able to see my Lambda app here. That is the group that I selected. And then I have a malicious file upload here that is not blocked because I put just to have the visibility that these kind of files are being uploaded to my system. So I have many different information about how this file actually reached my system, and I have my API gateway host header here. I have the resource request from AWS. I have the function name, and I also have the file name, confidential file, but underneath is actually a malware file. Okay, so the main reason here now I want to actually deploy the protection. So I'm going to malicious file upload, and I click on mitigate, and in a couple of seconds, I actually be able to block this file before I actually touch any part of the infrastructure of my application. So if I go to my serverless malicious upload again, and let me select the same file, confidential, and then I will be able to submit this file. And if we are asynchronized, probably going to block the file upload, and then has been blocked. And if I go to my Cloud Run Lambda function again, I'll be able to see the malicious file being blocked by application security. Same details will apply, but now I'm actually blocking this file to go inside of the flow of my application. So this is a very simple example on how you can do that using application security. The same applies if you want to use containers, if you want to introduce containers to this environment. So I have a Django app, a Python app that I have the Docker file here. I built and deployed to my own machine. So I could deploy this to AWS Fargate. I could deploy to Azure ACI and many other different serverless containers. I can also use that directly to my Kubernetes deployment if I want. I can also use application security to protect these containers over there. So I have many different parts of my application using the container. So I'm building the app as my code, and I get additional dependencies being set up. I have my database being set up here. And then I have the code that actually helps to deploy application security to this container. So I just need to install the micro agent that will actually make sure that you can deploy the protection, have the components to communicate with our backend. And I have a way to authenticate so I can put in the right group. So if I go here again to my Django app and I go to group configurations, I have the credentials to actually be able to deploy to the same group. In the same group, I will be able to customize what kind of security policies I do want to apply to it. Okay. So I have this Docker file. Then after I build this, And when I build, the result is my application up and running here in my local host. That could be on any cloud provider and could be on any other platform as well. Okay. So the only thing that I'll do, I run a attack simulation here just to see how the container will actually respond to it. So this is a simple vulnerability that I'm exploiting inside of my Django container, and it's already detected. And let's see the logs for this malicious payload. So this is malicious payload being blocked because I selected to block any vulnerability inside of this container. So in that case, I try to actually use a shell shock vulnerability. For now, it's already a very old vulnerability on this container, and this container at the same parameters using as the Lambda function, I'll be able to deploy the protection and actually to trigger the security controls directly from my Django app. So the bottom line here, let's go back to the presentation. Doesn't matter if you're using containers, if you're using serverless, as long as you're using web APIs, if you want to protect these web APIs, Cloud One Application Security is a very good fit for it, because we can deploy the detection and the protection directly to these apps without any kind of other barriers for the developers. They just need to add this directly to the code. They don't need to choose the right platform to secure these Lambda functions to these serverless functions or to these containers. They just need to add this directly to the code, and they can deploy this to any place they want. So they have the flexibility that they want to be productive and to be able to, at the same time, keep the security up to date inside of their applications that they are developing. So as I mentioned, this will not go, you don't need to choose restricted environments to actually be able to deploy the protection. You can deploy the protection anywhere you want, as long as you are using languages like Python, Java, Node.js, and many others that we support as well. As I mentioned, this is built for cloud native applications and also built for to be platform agnostic. So you can run any place, any cloud provider you want, you can run this platform, okay? So before I end, I actually want to enjoy a 30-day free trial for all the Cloud One modules. You can test your application security that we show here in this webinar. You can also run some tests on container security, conformity, and many other different modules. There will be many different sessions for these other modules here in this these different webinars that we are providing. And here you can go to cloud1.trainmicro.com/trial to get the trial up and running, or you can access this QR code as well. It will take you to the same place. And before I finish, I just want to thank everybody for being with us today. So this is my contact. You can send me an email, you can send me a Twitter. For sure I'll answer, and I will hear for the questions. I believe you have some, right, Yvonne?
Yes, thanks, Felipe, for a great demo. I always like to challenge our SEs to give us short, quick demos. And Felipe, we just had so much really great content today. So apologies if anybody has to drop, but we do have some questions in the chat that hopefully those folks who asked are able to stay on and listen to the answer. But if not, this is being recorded and everybody's going to receive that recording afterwards. So we do have a question here in the chat. Maria asks, will it block the malicious files if the app security is installed after the file upload?
Yeah, in that case, it will not. But as part of the cloud native application, if you have a flow that you actually, for example, will record this file to the S3 bucket, even after you actually deploy, file storage security will actually help with that. Because application security will only run after you actually deploy the protection. But if you already have the file over there in your S3 bucket, then we have a different module that can help you with this challenge as well. You can even use a combination of both. If you want to deploy this to your Lambda functions to be able to receive this file, you can deploy to the runtime part, and at the same time, in the same S3 bucket, you'll be able to deploy file storage security, any file that reaches there, even if it's not coming from a Lambda function, if it's coming from someplace else, we will be able to also scan. So this is the idea, to have different services to go to these different parts of the cloud native application. So be able to mix and match whatever is best for your use case specifically. Does that make sense? I believe so. Yeah.
Awesome.
There's another question here. Is there an install to be done on the cloud for the training micro part? So the only install that you actually need to do it, you need to activate your Cloud One console, and then you can retrieve the key and secrets that I showed a couple of minutes ago. And then you can deploy, you will have the Lambda layer that you can use it to your Lambda functions to actually be able to deploy this protection. And then you can use the as environment variables, the key and secrets to attach to the right group on the Cloud One application security. So the only thing that you actually needs to be done in the Lambda part is actually be able to put this layer, and then you're good to go. You don't need to install any server in your infrastructure because everything else is being done by the SaaS platform that we provide. So the only thing you need is this Lambda layer, the key and secrets, and activate your Cloud One account to be able to manage the whole application. On the other side, if you're running this in containers, what you need to do is to be able to install the package for your specific language. If I say, if you're running Python, can use pip and the train micro underscore app underscore protect. So this is our package that you can install. For Java is a different one. For Node.js is a different one. So as long as you install this and you set as environment variables the same key secrets, you'll be able to also deploy the protection. So we can say that is minimum installation that you can actually need to do instead of your production in your environment. Everything else has been done through the Trade Micro SaaS platform.
Awesome. We also have a couple of questions that came in ahead of time. Actually, okay, we have a question that just came in right now, so we can answer that live. Somebody said, what is the offering called that helps verify configuration of cloud configuration?
This is the conformity. So conformity, you'll be able to connect your cloud accounts and verify every single misconfigurations, or we can call it configurations out of the best practice for AWS, Azure, and Google Cloud. So you just connect your cloud account and you'll be able to read the metadata that you have there. So you don't have actual access to your resources. Just know what configuration, how you create that resource. So you'll be able to see the resource, and then you'll be able to tell you, okay, so this S3 bucket you created, but you're open too much the permissions, so you should close a little bit the permissions, and then you give all the best practices that you can follow for AWS in that example, for example.
Also got another question that just came in. Is AWS Lambda supported for Java? Don't see it is currently supported. Yes. And is there any time frame for that?
I need to double check, but I believe it's supported, but maybe I can answer this offline. I just need to double check, but I assume that is yes. But let me double check this and I can answer offline. Maria asked this question, right?
Yes, yeah. We can reach out to you via email, Maria.
Yeah.
Thanks for asking. All right, well, without keeping everybody too long, any other questions that we did have some that came in ahead of the webinar, but we can reach out to those folks individually and respond to them. Really appreciate everybody's time today and joining us. We'll be giving you guys a Uber Eats gift card in your inbox this week for spending that time with us today. Really appreciate you. Hope that you guys found some value in this content. Thanks, Felipe, for a great demo. Make sure you take advantage of our trial and our free tier offerings that he just mentioned, and hope to see you all at our next one. This one's going to be around remediating open source vulnerabilities in your open source code repositories and build pipelines via Cloud One open source security. That's happening next month. If you're interested in joining, again, the first Tuesday of every month, we'll be here for you guys. Thank you.
Thanks, everybody. Have a nice one.